Okay, so here we go. Day 2 notes. Test for parallelograms. So, what is a parallelogram? Well, first off, let's talk about the properties. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. And the big one, opposite sides of a parallelogram are parallel. Hence the name parallelogram. Okay, consecutive angles of a parallelogram are supplementary. Meaning they add up to 180 degrees. And diagonals bisect each other. Means they cut each other into 2 equal segments. Okay, so a little blurry on here, but you have it clearly on your paper. So this down here is 73. Which means this up here needs to be 73 because these are congruent to one another. We talk about consecutive, meaning the next one down. So this one right here is going to be supplementary to 73. So 180 minus 73, 107. So this is 107 degrees. And if this is 107, then this is 107 also. Okay, here we have 5y and y plus 8. Well, opposite sides are equal to each other. So 5y plus, equals y plus 8. Subtract y from both sides. 4y equals 8. Y equals 2. Which 5 times 2 is 10, 2 plus 8 is 10, and that works out. Now in the angles here, we have 4x and 2x minus 6. Well, what did we just say on the first example? 4x plus 2x minus 6 are supplementary. They add up to 180 degrees. So 6x minus 6 equals 180. Add 6 to both sides, you get 186. Divide by 6, and x equals 32. We plug it in. 4 times 32. It's 128. Those are 128. And then 2 times 32, which is 64, minus 6 is 58. Which doesn't make sense because 6 does not go on itself twice. X is 31. But it's a nice mistake to see because when I plug them in, they don't add up to 360 degrees. So 4 times 31, can be a little bit slightly different, is 124. And 2 times 31, which is 62, minus 6 is 56. If you notice, 56 and 124 equal 180. And if you add all 4 of them up, they equal 360. So that works out. Okay, so what we have here is one part of a diagonal and the other part of the diagonal. Like I said, blurry here, but they are equal to each other. So 3x minus 4 equals 2x plus 5. Subtract 2x and you get 1x. Add 4, you get 9. 9 times 3 is 27. 27 minus 4 is 23. 2 times 9 is 18. 18 plus 5 is 23. So each length of the diagonal is 23. Some more examples. The following are quadrilaterals. Solve the given variables to make these into parallelograms. Okay? Well, if this is 6, then this must also be 6. So A has to be 6. If this is 80, the opposite angle, x must be 80. If this is 80, this one y must be supplementary. 180 minus 80 is 100. Don't forget the degree symbol, sorry. And if this is 9, then b is 9. We now have a parallelogram. A little bit more over here on number 2. 3y plus 4 equals 13. 3y plus 4 equals 13. That's probably 33. Subtract 4. 3y equals 9. Y equals 3. So we have our first variable, y equals 3. Over here, 4x equals 8. Divide by 4, x equals 2. Here we have 18, and here we have 2w plus 8. So 2w plus 8 equals 18. Subtract 8, 2w equals 10. Divide by 2, w equals 5. I don't know why I started writing out the word equals. And then we have 4v minus 2 and 22. They're equal to each other. To be a parallelogram, these segments must be equal. These must be equal. So I'm going to add 2 to both sides and get 4x equals 24. Divide by 4, x is 6. Sorry, v is 6. Change my x into a v, I'm sorry. So now you have a parallelogram. Okay, 5 ways to prove that a quadrilateral is a parallelogram. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Opposite sides are parallel, meaning they have the same slope. And diagonals bisect each other. Last but not least, which of the following are parallelograms? Well, parallel, parallel, check. Opposite angles are equal, check. Parallel sides, opposite sides are congruent, check. Diagonals bisect each other,